This is Professor Derek Seitz. This video shows how to calculate hypothesis testing critical values for a standard normal distribution using Microsoft Excel. This would occur when hypothesis testing for a population mean, when sigma is known, or when hypothesis testing for a population proportion. The only input needed to this spreadsheet is the level of significance alpha, in this example, 1%. The spreadsheet calculates critical values for the three different types of hypothesis test: the left tail, right tail, and two-tailed test. The type of test is determined by the relational condition in the alternative hypothesis. Less than is a left tail test. Greater than is a right tail test. Not equal to is a two-tailed test. For the left tail test, the function used is norm.s.inverse, that's S for standard normal, B1, and notice that it's rounded to 4 decimal places. The right tail test uses norm.s.inverse 1 minus B1, which is alpha, and also rounded. The two-tailed test, the left tail, is norm.s.inverse B1 over 2, and that's rounded. And the right tail critical value is minus the left tail critical value. This calculation would be done as part of a hypothesis testing procedure. And as part of that procedure, to make a conclusion, you would reject the null hypothesis if the test statistic, the z-score for it, is in the rejection region for the appropriate kind of test being used. Again, this would be done in the context of hypothesis testing. It's separated in this spreadsheet here for convenience if you only want to calculate critical values on their own.